This is part 3 of addition of two numbers using linked list. So without any further delay, let's get started. The procedure of adding two numbers using linked list is divided into three parts. We have already seen this, right? What is the procedure of adding two numbers using linked lists? We have already learned in the previous presentation, that is how to represent an n-digit number using a singly linked list and how to reverse the singly linked lists, right? In this presentation, we will learn how to add the numbers and store the result in the resultant singly linked lists. So without any further ado, let's get started. Let's say we have two numbers 567 and 999, right? We have these two 3-digit numbers, right? Let me just represent these two numbers with the help of linked lists. You can see this, that these are the original linked lists which are representing these two numbers 567 and 999. You can see this, that this linked list is representing this number 567, right? 567. And this linked list is representing this number, that is 999, right? Currently, this head 1 pointer is pointing to the first node of this linked list and head 2 pointer is pointing to the first node of this linked list. Now, after this, we need reversed linked lists. Obviously, we have to reverse these linked lists. And this is how these reversed linked list looks like. You can see that the reverse of 567 is 765, right? And this is how the resultant linked list looks like, 765. And this is the resultant linked list, that is reversed linked list of this number, 999. Obviously, this will be 999 only, right? Now, after this step, we need two pointers for the purpose of traversal. Obviously, we need to traverse these lists, right? As you can see, now we have these units digits in the first place itself. We need two pointers that can point to these two nodes. And after this, it would be easy for us to add them and then proceed. That's why we need two pointers for the purpose of traversal. Traversal is required as we have to add two digits at a time, right? For this purpose, I have declared these two pointers PTR1 and PTR2. Currently, you can see that PTR1 is pointing to the first node of this linked list and PTR2 is pointing to the first node of this linked list. And there is one head 3 pointer which is currently holding this null. I want this head 3 pointer to store the address of the first node of the resultant linked list. That's why I have declared this head 3 variable over here. We will also need two variables to store the sum and the carry. Obviously, this is also an important step. For this purpose, I'll create two different variables, carry and sum. Carry is currently holding this value 0 and sum is holding this value 0. Both of them are holding the same value at this moment, that is 0 and 0, right? These are the representations of sum and carry. I used to represent them with boxes. I love to represent them with boxes. After this, we need this step for the purpose of addition, that is sum plus equal to PTR1 data, sum plus equal to PTR2 data. We know that PTR1 data is nothing but 7 and PTR2 data is 9, right? We just add PTR1 data to sum. Sum is 0. So 0 plus PTR1 data gives 7, which means that sum will now hold this value 7. After this, we must add 7 to PTR2 data, right? In order to obtain the result. 7 plus 9 is nothing but 16. So eventually, sum will hold this value 16. Isn't that so? So at the end of this piece of code, we'll get this value 16. Obviously, we also have to add the carry to the sum. Currently, carry is holding 0. There is no carry, of course, right? That's why 0 will be added to 16. But 16 plus 0 is 16. That's why this will not get affected. This value will not get affected at all. Now we can continue. You can see that we cannot simply add this value to the new node of the resultant linked list. Because this is not a single digit, we have to obtain a carry from it. Obviously, we have to pass 1 to the next digits. Here you can see this is 16. This means that 1 must be carry forward and 6 must be stored as a result. Here we have to perform this step, that is carry equals to sum divided by 10. This will give us the carry. 16 divided by 10 is nothing but 1. So 1 will get stored over here. After this, sum must also be updated so that it will become 6 at the end, right? Because sum equal to sum mod 10 gives this value 6. Now we can store this value in the new node. Now we need a function which can create the new node and push that node in front of the resultant linked list. I want that node to be pushed at the front of the resultant linked list, and this is important. We need a function which can create the new node. For this purpose, I will create this function push, and to this function I'm simply passing head 3 and sum. Okay. Obviously head 3 is null at this moment and sum is equal to 6. So actually I am passing null and 6 to this push function, and this is how my push function looks like. Here obviously this head pointer will receive null and val will receive 6. After this we have these 3 lines of code which will create a new node, and here you can see that new p pointer is pointing to the first node of this linked list, that is the new node. You can see the step also, that is new p link equals to head. Obviously head is holding null, so this will get replaced by null only. There is no effect. After this we have this line of code, that is head equal to new p. This means that head will get updated by this address 7000. So this means that it is now pointing to this particular node. Now everything is fine up to this point. We'll simply return head back, and here this head 3 pointer will receive that address, that is 7000. Receiving this address means receiving the linked list, right? We have received the address of the first node of the resultant linked list. Isn't that so? Okay. After this step, obviously we have to update our pointers because we are done with the step of addition. Now we must update our pointers so that it can point to the next nodes, right? You can see this, that PTR1 is currently pointing to the second node and PTR2 is pointing to the second node of this particular linked list. What is the next step? Obviously this whole thing must be repeated once again. Therefore, we must put this piece of code within a while loop. And here you can see that I have put this line of code, that is PTR1 or PTR2, which means that PTR1 not equal to null or PTR2 not equal to null. If PTR1 is not equal to null and PTR2 is not equal to null, then you can continue, otherwise just get out of this loop, right? Simple. Okay. If we simply write PTR1, then this means that we are writing PTR1 not equal to null. We know that the value of null is 0, right? If PTR1 becomes null, then this PTR1 will get replaced by null, and null means 0. And if PTR2 is also null, then this will also get replaced by 0. And we know that 0 is treated as false, right? So we will get outside of this while loop. And the value other than 0 will be treated as true. Therefore, we can continue. As you can see right now, PTR1 is holding this address 2000 and PTR2 is holding this address 5000. So it is clear that this will not yield 0. Therefore, we can get inside this while loop. And here you can see that we can simply add PTR1 data to sum. But wait, this step is wrong as sum variable is holding the previous value. You can see that the sum variable is holding the previous value, right? If we try to add PTR1 data to this sum, we'll get a wrong sum, right? We have to make it 0 before moving forward. That is why this line of code is important, that is sum equal to 0. We must put 0 over here before moving forward. Then after this, we can perform this step, right? Now here, first PTR1 data will get added to sum, which means that 6 will get added. Then after this, PTR2 data will get added to the sum. You can see that currently sum is 6. So 6 plus 9 is nothing but 15. And 15 plus carry, that is 1, is 16. Therefore, again, sum will hold this value 16. After this, the next step is divide sum by 10 and put that value inside carry. We know that 16 divided by 10 gives 1. So this will get replaced by 1. This means that carry will not get affected at all. And here, sum becomes 6, right? Now after this step, we'll simply call this push function, and to this push function, I have to pass the head 3 and sum. Head 3 means the address 7000 and sum means this value 6. This will get received over here, right? And after this, new node will be created with the help of this piece of code. You can see this new node is created, and obviously with the help of this line of code, that is new p link equals to head, we will get the address of this particular node and we will store that address within this link part of this node, right? So this will get updated by 7000 and you can see that it is currently pointing to this particular node, right? And after this, the next step is to update our head pointer so that it can point to this new node. In this way, we would be able to add this new node in front of this node, right? This is the resultant linked list so obtained, and head is currently holding this address 8000. Now we can get back to our place. Here head 3 pointer will receive this address 8000. After this, we have to update our pointers, right? But wait. Let's say instead of adding 5, 6, 7 and 999, user wants to add 67 and 999. Instead of having two 3-digit numbers, now I want that the first number must be 2-digit number and second number must be a 3-digit number. Okay, so let's see what happened in that case. Obviously, in that case, we will not have this particular node. Now, if we try to update PTR1, then obviously it will become null. And PTR2 will now hold the address of the third node of the linked list. Here you can see that after this step, PTR2 is pointing to this particular node, right? Now we will check this condition once again. Is PTR1 equal to null? Obviously PTR1 is null, but PTR2 is not null. You can see this is not null. Therefore, this will eventually give us true. We can get inside this while loop. Sum becomes 0, so let me update this with 0. After this, we'll perform this step, that is sum plus equal to PTR1 data. But PTR1 data does not exist, isn't that so? PTR1 is holding null at this moment. We cannot access PTR1 data. It is not pointing to any node. How do we able to access PTR1 data? There is no way to access PTR1 data. It may produce an error, right? Now how to eliminate this problem? The one way to eliminate this is to put this line of code inside this if construct. That is, we must check this. If PTR1 is not equal to null, then we will perform this step. Otherwise, we'll get outside of this if construct. Simple. I'm simply writing PTR1 instead of PTR1 not equal to null because they mean the same, right? Here, if PTR1 is null, we'll simply get outside of this if construct. We can see that PTR1 is null. Therefore, we'll get outside of this if construct. Similarly, we have to put this line of code within this if construct as well. Obviously, it might be possible that PTR2 becomes null before PTR1 becomes null, right? That is why we must have to put this line of code within this if construct as well. Now it makes sense to us, right? If PTR1 is equal to null, then we'll get outside of this if construct. We'll not evaluate this line of code. Obviously, we will not. But here PTR2 is not null. Therefore, we'll get inside this if construct and we will add PTR2 data to sum. Sum is currently holding 0, and what is PTR2 data? PTR2 data is 9. So we'll store 9 over here. After this, the next step is sum plus equal to carry. What is sum plus equal to carry? Carry is 1. So 9 plus 1 is 10, right? So let me just replace this by 10. After this, the next step is carry equal to sum divided by 10 and sum equals to sum mod 10. We know that sum divided by 10 will give 1 as a carry. And obviously sum will hold this value 0. Now we can simply call this push function, and to this push function, I will pass the head 3 and sum. Sum is 0, so this will get replaced by 0. And head 3 is 8000, so this will get replaced by 8000. Let's just get back to the push function. And after this, obviously new node will be created, and this new node will point to this particular node because of this line of code, that is new p link equals to head. And after this, head must be updated so that it can point to this particular node. And this is how the resultant linked list looks like. 066 at this moment. After this, we'll return head back. Here this head 3 pointer will receive this address 9000. After this, we have this line of code. PTR1 equals to PTR1 link, but PTR1 is null. There is no PTR1 link. PTR1 link does not exist. Hence, it may generate an error. That is why we'll do the same thing which we have done over here. That is, if PTR1, then PTR1 equal to PTR1 link. If PTR2, then PTR2 equal to PTR2 link. Right now, you can see that PTR1 is null. Therefore, this line of code will not get evaluated. But PTR2 is not null, right? Therefore, this will get evaluated. Hence, PTR2 becomes null after this line of code. Then we will again check this condition, is PTR1 equal to null or PTR2 equal to null? Obviously, both of them are null. Therefore, we'll get outside of this while loop. But wait, what about the carry? What about this carry? Obviously, we have this carry at the end, right? We have to create a new node and add the carry to the data part of that node. So it is important to add this piece of code as well. That is, if carry, then head 3 equals to push head 3 comma carry. Here instead of sum, we'll pass carry. Okay. We have to create a new node which will store carry in its data part, right? And you can see that instead of writing carry not equal to 0, I'm simply writing carry. Okay. This is okay, because if carry is 0, then we'll simply get outside of this if construct, but carry is 1 at this moment. Therefore, we'll get inside this if construct, right? And here we'll simply call this push function and pass head 3 and carry to it. Head 3 is 9000, so 9000 will be passed, and carry is 1, so 1 will be passed to push function. Here head will receive 9000 address and val will receive value 1, right? After this, the next step is to simply create the new node. And you can see that 1 is added at the data part of this node. And you can also see that link part is updated by the address of this particular node, right? And this is our new p pointer. And I'm assuming that the address of this node is 9999. Okay. After this step, obviously head pointer must be updated so that it can point to this node. And this is the resultant linked list so obtained, that is 1066. This is our result. Obviously, the addition of 999 and 67 is 1066, right? Then after this, we'll return head back, Here this head3 pointer will receive that address. This means that this particular pointer will also receive this address 9999. This means that we have an access to the complete linked list. Now let me just show the complete code in code blocks. Here you can see this is the complete code for adding two numbers with the help of linked lists. Here you can see we have this push function. We have this add function. In this add function, I have added this piece of code as well to check if head1 data is equal to 0, then return head2. Else, if head2 data is equal to 0, then return head1. Otherwise, simply continue, right? You're already familiar about this piece of code. And this is reverse LL function, add node function, create LL function, print function. We have this back to num function also. I've added this particular code as well. And here we have this main function. You can see that here I have declared head3 pointer, and after this I'm simply calling this add function, which will add the two numbers, and it will simply return the address of the resultant linked list. That is the address of the first node of the resultant linked list, right? After this we can use that address and simply print the whole linked list on the screen. Now after this I'm calling this back to num function also, and to this function I'm simply passing head3, which means the address of the first node of the resultant linked list. After printing the whole linked list, I just want to print the complete number. Okay, that's why I'm calling this back to num function. And here in this back to num function, you can see that I have declared a temp pointer for the purpose of traversal, obviously. And I'm calling the printf function to print this message on the screen, that is result equal to. And then with the help of this while loop, I will simply traverse the list. And here you can see I'm not writing temp not equal to null. I'm simply putting temp, right? You already know the logic behind this. And within this while loop, you can see I'm writing printf %d temp data. So I'm just simply accessing the data of each and every node, and I'm just simply printing them on the screen. And obviously after this temp pointer must be incremented, and this process will continue in the same way, right? So let me just execute this code. Let's say the two numbers are 67 and 999. You can see the results obtained, that is 1066, right? Let me just execute it once again. This time, let's say I want to add these two numbers. You can see the results obtained, that is 109998, right? I hope the whole concept of adding two numbers with the help of linked list is clear to you. So we have completed this part, that is addition of numbers and storing the result in the resultant singly linked list. This means that addition of two numbers with the help of linked lists is now completed successfully. Okay friends, this is it for now. Thank you for watching this presentation.